In this video, we're going to talk about 7.4.1, which is derivatives of a transform, a Laplace transform. So let's go ahead and start with number 1 from section 7.4, and then this is the 7.4.1 objective problems, the first set. So the Laplace transform of t e to the negative 10t is going to be equal to negative d ds of the Laplace transform of e to the negative 10t. That's based off of the definition in your book that Laplace transform of t to the n f of t is going to be equal to negative 1 to the n dn dsn of the Laplace transform of f of t. Which is also written as negative 1 to the n dn dsn of f of s, like that. So this is negative d ds of, and then Laplace transform of e to the negative 10t is 1 over s plus 10. So that's going to be a negative. And then we have s plus 10 to the negative first. So that is a negative 1 over s plus 10 squared. So the negatives will cancel each other out and give me a positive 1 over s plus 10 squared. Let's look now at number 3. Laplace transform of t, cosine of 2t is going to be equal to a negative d ds. The Laplace transform of cosine of 2t, it's s over s squared plus 4. So we have negative, and we have derivative at the top times the bottom, minus derivative of the bottom times the top, all over the bottom squared. My quotient rule. It's going to be negative s squared plus 4 over s squared plus 4 quantity squared. Distribute this negative over the numerator, and we get s squared minus 4 over quantity s squared plus 4 squared. Let's look at number 5. That is Laplace transform of t squared sine, hyperbolic sine of t. So that's going to be -1 squared d2 ds2 of 1 over s squared minus 1. So -1 squared is 1. We have the derivative of the derivative of s squared minus 1, negative first. That's the derivative of negative s squared minus 1 to the negative second times 2s would be the derivative with respect to s of a negative 2s over s squared minus 1 squared. That -2 can come out. So s over s squared minus 1 squared. So we have a quotient rule now. Derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. It's going to be like so. -2 times -3s squared minus 1 over s squared minus 1 to the third is going to give me 6s squared plus 2 over s squared minus 1 cubed. Moving along to number 7. And Laplace transform of t e to the 2t sine of 6t. So that multiplier of t is going to give me a -1 to the first. And then the first derivative of, and then I'm going to have sine is going to be 6 and 36. And this is 2. This is s minus 2 squared. So that's going to be a negative derivative with respect to s. Let's go ahead and pull the 6 out. And this is going to be 1 over s squared minus 4s, and then plus 4 plus 36 is plus 40. And so that's going to be -6 ds of s squared minus 4s plus 40 to the negative first. So that's going to be a -6 times a -1 s squared minus 4s plus 40 to the negative second times 2s minus 4. Negative will be a positive. 6 times 2s minus 4 is my numerator. My denominator is s squared minus 4s plus 40. So that gives me 12s minus 24. My denominator can go back to being s minus 2 squared plus 36. And that gets squared. This is to the negative second power, so that's a 2 in the denominator. So there's a 2 on the whole thing. Let's look at number 9. And this is going to be an initial value problem. Do 9 and 11. So 9 is y prime plus y is equal to t sine of t with y of 0 equal to 0. So I have s capital Y of s minus y of 0 plus capital Y of s is equal to, and using your table of Laplace transforms, you can find that the Laplace transform of t sine of t is 2s over s squared plus 1 quantity squared. This is 0. This is s plus 1. Y of s is equal to 2s over s squared plus 1 quantity squared. So y of s is equal to 2s over s plus 1 times s squared plus 1 quantity squared. So that needs to be equal to something over s plus 1 plus bs plus c over s squared plus 1 plus ds plus e over s squared plus 1 quantity squared. And let's go ahead and solve that. A times s squared plus 1 quantity squared plus s plus 1 times s squared plus 1 times bs plus c plus s plus 1 times ds plus e is equal to 2s. So that is a times s to the 4th plus 2s squared plus 1 plus, this is s cubed plus s squared plus s plus 1 times bs plus c plus ds squared plus ds plus es plus e is equal to 2s. I have a times s to the 4th plus 0 s to the 3rd plus 2s squared plus 0s plus 1 plus b times s to the fourth plus s to the third plus s squared plus s plus 0 plus d times, sorry, I'm on to c times s to the third plus s squared plus s plus 1. There's 0s to the fourth there. So I should write for myself cubed plus s squared plus s plus 1 plus d times 0s to the fourth plus 0s to the third plus s squared plus s plus 0 plus e times 0s to the fourth plus 0s to the third plus 0s squared plus s plus 1 equals 2s. Why am I writing all those zeros? Because I'm going to turn this into a matrix. And I want to just be able to read each of these and make a column in my matrix. So my column is 1, 0, 2, 0, 1 for A, then 1, 1, 1, 1, 0 for B, and then 0, 1, 1, 1, 1 for C, and then 0, 0, 1, 1, 0 for D, and then 0, 0, 0, 1, 1 for E, and then my 2 is in my S's, everything else is zeros. Let me just take a look at that. 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, 2, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 2, 1, 0, 1, 0, 1, 0. Excellent. So when I RREF that, I'm going to get a solutions or a matrix that is going to look like this. 5. I get negative 1/2, positive 1/2, negative 1/2, 1, and 1. So that turns into my capital Y of S is equal to negative 1/2 times 1 over S plus 1 plus 1/2 S over S squared plus 1 minus 1/2 of 1 over S squared plus 1 plus 1S over S squared plus 1 plus 1 over, this is squared, S squared plus 1 squared. Now we're going to need to do a little bit of algebra before we can do inverse Laplace transforms on this, specifically to get one of my terms for my t cosine of t. So my y of s is equal to my negative 1/2, 1 over s plus 1, that term is fine, plus 1/2 s over s squared plus 1, that term is fine. But now I need to get this term that has the s in it to be able to combine with this term over here. So I'm going to need to make this minus 1/2, make it s squared plus 1 squared over, and then make this s squared plus 1 like that. So that's that term plus s over s squared plus 1 squared plus 1 over s squared plus 1 squared. So that makes y of s equal to, and let's see, I need to make another adjustment here for this one. I'll do that in just a second. So minus 1/2 of 1 over s plus 1 plus 1/2 of s over s squared plus 1. And then I have plus a negative 1/2 s squared minus 1/2 plus 1 over s squared plus 1 squared plus s over s squared plus 1 squared. That's going to give me capital Y of s is equal to negative 1/2 of 1 over s plus 1 plus 1/2 of s over s squared plus 1 plus a negative 1/2 s squared plus 1/2 over s squared plus 1 squared. Now I need to have a 2ks up here, so I'm going to make this 2s, the multiplier of 1/2 s squared plus 1 squared, and I'm going to factor out that negative 1/2. Y of s is equal to a negative 1/2, 1 over s plus 1 plus 1/2 s over s squared plus 1 minus 1/2, and that leaves me with s squared minus 1 over s squared plus 1 squared plus 1/2 of 2s over s squared plus 1 squared. S squared minus k squared over s squared plus k squared squared. It's exactly what I need for that term. So this is negative 1/2 e to the negative t plus 1/2 of cosine of t minus 1/2 t cosine of t plus 1/2 t sine of t. One more problem, I promise you it's much shorter than that. That was the hardest problem. So let's look at number 11. We have y double prime plus 9y equals cosine 3t, y of 0 equals 2, y prime of 0 is equal to 5. So I have s squared capital Y of s minus s y of 0 minus y prime of 0 plus 9 capital Y of s is equal to s over s squared plus 9. And we have s squared plus 9 capital Y of s minus 2s minus 5 is equal to s over s squared plus 9. So s squared plus 9 capital Y of s is equal to s over s squared plus 9 plus 2s plus 5. Capital Y of s is equal to s over s squared plus 9 plus 2s over, this is squared now, 2s over s squared plus 9 plus 5 over s squared plus 9. So I need this to be a 2ks where k is 3. So I need a 6 and a 1/6. And then this one is okay. It's going to be s over s squared plus 9. And then this one needs to have a numerator of 3. It currently has a numerator of 5. So I need to multiply by 3 and divide by 3. So y of s equals, so y of t is equal to 1/6 t sine of 3t plus 2 cosine of 3t plus 5/3 sine of 3t. That's going to be it for this video, and I'll come back next time and talk about 7.4.2. So see you for the next video.